All right, ladies and gentlemen, we are on notes 8.4, which are on domain and range. So let's take a look at what it says right on top. Ultimately, all functions do is convert inputs into outputs. Hopefully you've understood that point by now. So each function has two sets associated with it. Those things that serve as inputs and those things that serve as outputs. These sets are given names. So the names are all listed right here. The domain and the range of a function. The domain of a function is the set of all inputs for which the function will give an output, and the range of a function is the set of all outputs for which there is an input that results in them. So again, it's really important that you understand that domain is associated with the inputs. It's the set of all inputs, and the range is just basically the set of all outputs, okay? So let's look at exercise number 1. We're going to build an understanding of what domain and range are based on our exercise number 1 right here. So it says consider the function y equals f of x shown on the graph below. Question A, evaluate each of the following. Please go ahead and try to figure out each of the following and then come back to me to see how you did. All right, so f of -3 you should have gotten is 1 because x is -3 right here, so you should get 1. F of 1 is going to be equal to -3 because that's the output when the input is 1. And then f of 3, the input is 3, the output is 1, 2, 3, 4, 5. So f of 3 is equal to 5. So question B, can the function rule given by the graph give you a value when x equals 5? So let's look and see if this is a possibility. So I'm going to go to the x-axis and I'm going to look at 5. So 1, 2, 3, 4, 5. Do I have any corresponding value of my graph when x equals 5 here? There isn't. So what we're going to say is no, it's not possible. Because f of x, the graph f of x doesn't have an input of x equals 5. There is no point on the graph where x equals 5, okay? So then question C, is x equals 5 in the domain of the function? Well, let's look back and remind ourselves of what domain is. So domain is the set of all inputs, and 5 does not have an output, so that means that 5 is not an input. So we're going to say that no, x equals 5 is not in the domain. So question D says, give two other values of x that are not in the domain of the function. So all I have to do is find out where there are no points in the function. So for example, right here, I can say that -1 is in the function because it has a point down there. I can say that 3 is in the function because it has a point that it lines up with right here. However, I cannot say that this point right here has a corresponding y value. So right here, I do not have a corresponding y value. So at 1, 2, 3, 4, 5, 6, there is no corresponding y value. So x equals 6 is one example where it's not in the domain. Another example where it's not in the domain is over here. There's no corresponding y value here. So at 1, 2, 3, 4, 5, 6, at -6, there is also not a value. Okay, so E, circle the following y values that are in the range of the functions. Show evidence on your graph. So when y equals 0, I'm going to look and see where y is equal to 0. So y equals 0 right here. I've got 1, 2, 3 points that match up with the graph. So y equals 0 is within the range because this output comes from a specific input. Then I'm going to look and see y equals 6. So 1, 2, 3, 4, 5, 6, y equals 6. There is nothing from the graph that intersects with y equals 6. So that is not going to be in my range, okay? And then y equals -1 right here is right here. So y equals -1. I also have some coordinates that intersect at -1. So this is within my range. Okay, so question F, write the domain and range of this function using a single inequality. Well, the domain, remember, we defined is the set of all inputs right here. So again, if it's the set of all inputs right here, I'm going to look and see what inputs work. So it started right here at this value. This is my first value that I have, my lowest x value that has a corresponding output for my input. So -5 is my lowest x value, and it goes all the way through until I get to this point right here. This is my highest y value, which is at 3. So it goes from -5 to 3. So my domain is going to be right here from -5, but -5 is included in my domain. And my domain is my input, so it's my x values, all the way up until 3. So here's my single inequality that will satisfy all the values that I will have for my domain. I can also write it in interval notation, and it would be from -5 until 3 like this. Okay? So now my range, I have to look and see what are my corresponding y values. What's my lowest y value and what's my highest y value? Well, this is the lowest it will go right here. So this is at -1, 2, 3, 4. All right. And then this right here is the highest that it will go. So let's erase this a little bit so we can see it. So this is the highest my value will go. So that's at 1, 2, 3, 4, 5. Okay, so it goes from -4 to +5. But don't forget that your range are your y values, okay? But really, we're going to use f of x instead. So that means that the lowest y value I have is -4, but it includes -4. So -4 is less than or equal to f of x, which is less than or equal to 5. Okay, and then if I wanted to write this out as an interval, it would be -4, 5, both with closed brackets. All right, exercise number 2. Given the function f of x equals x over 2 minus 3 and the domain shown below, fill in the range. Write the set in roster notation. So our domain are sets of inputs that work, right? Remember, we just learned that that's the definition of domain. So it's all the inputs that work, okay? So now our inputs are -4, 6, and 10. So that means I have to find my corresponding outputs. So if there's only 3 inputs, then I will only have 3 outputs. So let's figure each one of these out. So if I have f of -4, I would just have to do -4 over 2 minus 3, which gives me -2 minus 3. So that means that f of -4 is equal to -5. Okay? So now let's figure it out for 6. So I'm going to do f of 6 is equal to 6 over 2 minus 3. So I end up getting 3 minus 3. So that means that f of 6 is equal to 0. All right, and then lastly, let's do f of 10. So f of 10 is equal to 10 over 2 minus 3. So I get 5 minus 3, which is equal to 2. So that's what f of 10 is. So that means that my 3 values in my range are -5, 0, and 2. So I've got -5, 0, and 2. And when I draw my mapping, I know that -4 goes to -5, 6 goes to 0, and 10 goes to 2. So that means that my range is simply -5, 0, and 2. Now the reason why this is called roster notation right here, because that's what it said to do, so I'll write it out, it's -5, 0, and 2. And the reason why this is roster notation is because I can actually list out in a roster all the values that are in my range. I only have 3 answers. I have a finite number of answers. However, if you look back at the previous exercise right here, our domain and our range here, our range was from -4 to 5. So that means that it's every single possible value from -4 to 5, including all sorts of decimals, rationals, irrational numbers, every real number between -4 and 5, which means you have infinite values in your output right here. And the reason why you can say that you have that is because this is continuous. It goes here, it goes up, it goes down, it goes up, but it covers every single value within this section right here, okay? Every single thing from -4 to 5 is covered in this section over here, all right? As opposed to the next example in exercise 2, where you have simply 3 values and that's it. So I listed out my 3 values. Hopefully you understand the difference between the two. All right, exercise number 3. Which of the following values is not in the domain of the function f of x shown below? Illustrate your thinking by marking points on the graph. So all I have to do is look at my graph and see which values are in my domain. Domain, remember, is your set of inputs, your x values. So I'm going to go on my x-axis and I'm going to look for -3. So -1, -2, -3. Here's -3. I have a corresponding output. So it is within my domain. So this one works. It is within my domain, but I'm looking for the one that's not within the domain, okay? So let's look at choice 2. Choice 2 says -4. So I'll use a different color so you can see it. -1, -2, -3, -4. Right here, I still have a corresponding output, so that works as well. So -4 is within my domain. All right, choice 3 says 5, so I'm going to go to 5. 1, 2, 3, 4, 5. There is no corresponding output for 5, so that means that 5 is not within my domain. So that's the one that I'm going to look for. But let's just make sure that 0 also is within my domain. So I go to 0 on my x-axis, and I look and see if there's a corresponding output. There is, so 0 is within my domain, okay? All right, exercise number 4. Consider the piecewise linear function given the formula f of x is equal to negative quantity x plus 2 over 2 for -4 to 2, and then 4x minus 10 for 2 to 4. Determine the function's range. So in order to do that, I'm going to draw a graph of it. In order to draw a graph of it, I need to create a table, okay? So let's create our table right here. I've got my x values, and then I've got my f of x values. And it tells me that my x values, it gives me my domain right here. It tells me where it works. So it works from -4 to 2 and then 2 to 4. So altogether, my domain is going to be from -4 to +4, okay, including all possible values. You can go by however you want in your chart. For me, I prefer to just do every integer because that's nice and easy for me, okay? So I've got -4, -3, -2, -1, 0, 1, 2, 3, and 4, okay? Now, I'm not going to have you do every single one of these by hand. I'm going to show you how to plug this into your calculator. However, you know how I told you have to show at least one by hand? When it's a piecewise function, you have to show one of each piece by hand, okay? So let's do the first piece by hand. The first piece, -4, falls within the first piece because it's between -4 and 2. So I'm going to do -4 plus 2 all over 2. This is to find out what f of -4 is. Okay, so this ends up being f of -4 is equal to -2 over 2. So I end up getting that f of -4 is equal to +2 over 2, or just plain and simply 1. Okay, hopefully that makes sense to you. All right, now the next piece starts when x is 2. So I'm going to figure this out right here. This is where my next piece starts. So I'm going to figure out what f of 2 is. So f of 2 is going to equal, I'm going to use the bottom function. So I'm going to say 4 times 2 minus 10, which is 8 minus 10, which you get -2 is your answer. So that means that f of f of 2 is equal to -2. Okay? All right, so now how do I plug the rest of this into my calculator? Open up your calculator and you need to create a graphs document. So choice 2, a graphs document. And this is how you get your piecewise function. If you look right here, this button right here, right next to the book button and next to the 9, right in between them, you have a lot of choices. If you click on it, you will see all of your options right here. This one and this one are both piecewise functions. This one is just if there's 2 pieces. This button you would use if there's multiple pieces and you define how many pieces there are. You can always use this button, even if it's just a 2-piece piecewise function. This one you can only use if it's 2 pieces, okay? So I'm going to use this one and I'm going to show you how to use it no matter how many pieces you have. So if you click on it, right here, it says to define the number of pieces. There were 2 pieces in your function. If you look at it right here, here's the first piece, here's the second piece, all right? So let's go ahead and say that there's two pieces right here, okay? And we'll click OK. So now here, what I'm going to do is I'm going to type in my first function. So my first function requires a fraction, so I'm going to put my divide sign right here, and there's my fraction. And then what it says is negative, and then in parentheses, I've got x plus 2. Close your parentheses, and that's all over 2. Okay, but this only works between -4 and 2. So what we say is -4 is less than, remember you press Control equals to get the less than or equal to sign, and then we type in x right here, and then we do Control equals again to get the other sign, so it's from -4 to +2. Okay, and then here I'm going to type in 4x minus 10, and this works from 2 to 4. And there's where our graph is going to be. This is what our graph looks like, okay? So in order to get my corresponding outputs for my inputs, all I have to do is go to Menu, Trace, and Graph Trace, okay? So once I do that, I go back to my graph right here. I need to figure out what -3 is. So my input is -3. So all I have to do is type in -3 right here. Press enter. In the corner, it gives you the coordinate. It's 0.5 or 1/2. Okay, so I'm going to type in right here that this is, or not type in, I'm going to write in right here that this is 1/2. So this coordinate is going to be -3, +1/2. Let's do the next one. Let's see what you get. You should type in -2. Enter, you should get 0. Okay, so once you do that, right here, I'm going to type in, or I'm going to write in a 0. Please go through and figure out the remaining values and then come back to me to check to make sure you have the right values. All right, so these are the values that you should have gotten. You should have gotten 1, 1/2, 0, -1/2, -1, -1.5, -2, 2, and 6. So now we just have to graph out our coordinates. Okay, so go ahead and graph out your coordinates and then come back to me when you're done and make sure that it's all good to go. All right, so this is what your graph should look like. Notice how I have a starting point and an ending point. I don't have arrows because it's only defined from -4 to 4. So now the question is, what is the range? Okay, so the range, I have to look at my lowest value right here. So my smallest y value all the way to my largest y value. So it's from -2 all the way up to +6. So that means that my range would be -2, including -2, all the way to 6. Or I could say -2 is less than or equal to f of x is less than or equal to 6. All right, make sure to come with any questions if you have any. I hope you have a wonderful day.